So what we are starting today is dealing with two-way tables, and two-way tables can just be a really good way to show data so that you can use it to say, what is the probability of somebody wearing a red shirt if they're in ninth grade or stuff like that. Okay, and so we use them a lot for conditional probabilities. That's what we're going to get into more tomorrow, but today we're just going to talk about two-way frequency tables, what two-way frequency tables are, and then two-way relative frequency tables, which are slightly different. The word relative makes a difference there. Okay, so two-way frequency tables. Frequency means how frequently this happens. So two-way frequency tables just have numbers in terms of how frequently something happens. What we're going to fill in over here, it says frequency tables are used to examine relationships between two sets of categorical, like categories, categorical data. They are used to analyze, survey, or poll results to find associations. When constructing a two-way frequency table, make sure to use total columns to organize the data correctly. Okay, so we're going to add on to this. So 50 students were polled on whether or not they had an iPhone and whether or not they liked shopping. Okay, so we know that there's a grand total for the entire table is going to be 50 students. Complete the frequency table given the following information. 26 students like shopping. Okay, 26 students like shopping. This is not telling me whether they have an iPhone or not. So they're saying altogether 26 students like shopping. So that means that, let me go ahead and just add some boxes for my totals. And I'm going to have row totals and I'm going to have column totals. 26 students like shopping. 37 students have an iPhone. Have an iPhone, 37. 23 students have an iPhone but don't like shopping. Now that's finally giving me some information here in the individual categories. So have an iPhone is the top row. Don't like shopping is right here. So there are 23 students right here. So now what I can do is I can subtract basically to find out the other categories. Now, way back up at the beginning, it said 50 students were polled. The grand total goes right here. That's like my grand total of everybody in this table. And the way the table works, every row and every column should add up to the number at the end of the row or the end of the column. And that also includes here. The totals here should add up to 50, and the totals here should add up to 50. So if 26 people like shopping, 50 people total, 50 minus 26 tells me 24 people don't like shopping. Okay, so I could go ahead and finish this column right now. There's not a particular order you have to do it in. It's more just like as you see it. And I saw this and going, oh, well, if 23 don't like shopping but do have an iPhone, then only one must not like shopping and not have an iPhone because there's a total of 24 in that column. Bless you. And I could also finish this row off pretty easily. People who have an iPhone, 23 of them don't like shopping. There's 37 total. So how many should like shopping? 14, good. 14 plus 23 equals 37. And then I can add up this column or finish off this column. That would be what, 12? And 12 plus 1 adds up to 13. And I know that's correct because 37 plus 13 adds up to 50. So that's me finishing off the table. So that's just all we've done there is we've just created a frequency table. Okay. And frequency table means these are just numbers, how frequently that happens, how frequently someone doesn't have a phone and likes shopping or does have an iPhone and doesn't like shopping, that kind of thing. Okay. So relative frequency, and I actually showed you the next page, but we're getting into it here. Relative frequency is closer to probability. It's like how many people said this out of how many people. Okay. So relative frequency is a decimal or a percent. It's not like a number like a count that represents the ratio of a given part and whole. To calculate relative frequency, you determine the part and the whole the question's asking about. Like how many what's out of what. You got to figure that out. What are they asking me to look at? And then you divide. If you want to do it as a percent, you would multiply the decimal by 100. Okay, so this two-way frequency table is filled out for me. This is a frequency table because it's numbers that are like a count. It's not decimals. 100 students were polled. Okay, let's go ahead and finish my columns and rows. 100 students goes right here. That's the total number of students polled. That is not the prettiest. You don't necessarily have to make boxes. You could just put the numbers outside there. Okay, chores. This is 20. This adds up to 80. I must have those right because those two do add up to 100. These add up to 32. These add up to 68. And again, 32 plus 68 does equal 100. So we're good there. Okay. How many students had no curfew? Okay, that's a total of 68. How many students had no chores? So how many is frequency? The words how many, that's a frequency question. No chores. So that's this row, that's 80. How many had no curfew and no chores? So that's like an intersection of the two, like a row and a column. So no curfew meets no chores right here. So 64 students have no curfew and no chores. Find the relative frequency of having to do chores. Okay, so the people who have to do chores, that's these people, 20 people. Relative frequency, they didn't tell me of people who don't have a curfew or of people, they just said the relative frequency of people who have to do chores. So they're talking about out of everybody. It's right up there. Thank you. They're talking about out of everybody. So that means I'm going to put 20, these people who have chores, out of the whole group, which is 100. So that's a relative frequency. Anytime they're talking about a relative frequency, that is a decimal. That's going to be division, and it's going to turn to a decimal. And that would be 20%. Usually we'll do it as a decimal, though, instead of a percent. I feel like my pen is running dry, which is a shame because it's my favorite. I'll make it through this page. Find the relative frequency. So relative frequency means I need to divide of having to do chores among those who have curfew. So this time they told me my bottom number needs to be narrowed down just to the people who do have a curfew. So people who do have a curfew, there are 32 of those. Find the relative frequency of having to do chores, that's these people, out of those 32. So 16 out of 32 is what that is. And that is half. And I think the idea, like you could make some conclusions, or you would maybe not necessarily conclusions about what your data shows in terms of, are parents who give their students a curfew more likely to also give them chores? Yes or no, that kind of thing. That's the kind of stuff you could do with this data. All right, back of this page. Students were polled at lunch whether they preferred Nike or Adidas shoes. The data was filled in the table, but some of the data is missing. Complete the missing table in the data. Data in the table. I'm actually thinking about letting you guys do this without me. And we'll go ahead and do this. So first row. So any of these that's the blank, we have to fill in. First row has to add up to 35, sorry. So that would be 13. And this row has to add up to, what is that, 30? And then this column adds up to 33. This column adds up to 32. And all of it adds up to 65. So that's good because that kind of checks that we've done it right, because these two add up to 65 and these two add up to 65. After completing the table, answer questions about the data below. Okay, what was the relative frequency a boy was polled? So relative frequency means divide. I'm going to divide boys by everybody. Okay. So boys, there are 35 boys, and total people polled is 65. So 35 divided by 65 gives me 0.54, like 5.538 something. I'm going to say 0.54. What is the relative frequency? Okay, so again, I have to divide, of selecting a boy out of the people who prefer Adidas shoes. So now we're narrowing it down to just these 32 people, the people who prefer Adidas. Boys out of that group is 13 out of 32. So 13 out of 32. And I get 0.41. Okay, does there appear to be an association between being a boy and preferring Adidas shoes? I would say no. Like, there's different ways you could ask that. You know, there's positive associations and there's negative associations. So you could say there seems to be a negative association, like if you're a boy, you seem less likely to prefer Adidas shoes. I'm really not as interested in questions like this because we're not going to be really looking at stuff like that. Yes?
So like for a question like that, we just look at like, how do we answer a question like that?
You can look at the whole thing. That's what I'm talking about right now. So you can look at the whole thing, like the table up here, and say, does it seem like it's more likely or less likely to like Adidas if you're a boy?
So like if it's more likely it's positive association, it's less likely it's negative?
Yes, but they're not getting into that really. They're just saying that there appear to be an association. So that's what I'm wondering, if they're asking about positive association. You could just say, you could say something general like more boys like Nike. That's fine with me. I'm really not that worried about that type of question. Unless it's like an overwhelming, obvious trend. What is the relative frequency of girl was? Okay, I'm going to let you guys do numbers 9 and 10 real quick. Looking ahead on this worksheet, really, they're saying when they ask, is there an association? They're really asking, is there a positive association? And I would say no, because more boys like Nike. And also because only 41% of boys like Adidas. It would have to be more than half for me to say, yes, there's a positive association. Okay, so relative frequency, a girl was polled. Let's see, there's 30 girls out of 65 people. So 30 out of 65. And I change that to a decimal. And I get 0.46. What is the relative frequency of selecting a girl out of the people who prefer Adidas? So people who prefer Adidas, remembers those 32. A girl is 19. So 19 out of 32. Okay, and that's 0.49. Okay, now, I'm sorry, 0.59. I said 0.4, didn't I? Sorry. Does there appear to be an association between being a girl and preferring Adidas shoes? I'm going to say yes. And like I said, reading ahead on this worksheet, how they're answering questions, I'm going to say yes because 0.59 is basically more than half. More than half the girls liked Adidas. So yes. Okay. Write a sentence that summarizes the data. And they're just basically saying boys tend to like Nike and girls like Adidas. That's what that loosely shows. Now, you guys may remember from when you did data and this kind of thing in 7th grade. I tutored a student one time in 7th grade, and one of the things that was interesting to me was how many questions all had the same answer. And that answer was, you need a bigger sample space. This little poll of 65 people, this would not be something that, Adidas would want to hinge a whole, ad campaign on and like reach out to more boys, because obviously boys don't like them. 65 people is not a lot. So the conclusions we're drawing here are very loose conclusions. We cannot really say, oh yeah, this is definitely true, that, this shows me. And that's something you have to be careful about with statistics. If somebody says, more women support this political candidate or something like that, how many polls told you that? Was it just one poll? Because just one poll is not necessarily that reliable. How many people did that one poll sample? So a lot of times, we get a lot of statistics thrown at us. A lot of the statistics thrown at us is taken out of context and is taken from just very small samples. And you're like, if I could actually, if you could look into who did you poll, how was this poll done, etc., you'd find a lot of them were not done as scientifically as you would want to say, yes, this is definitely a conclusion I can make from this data. Okay. So yeah, just like back in middle school, you were constantly saying, what could make this more accurate? A larger sample size. This is definitely not enough people to make some huge conclusions on. All right, moving on. We're still with Nike and Adidas. I'm not really sure why we have to stay with them so hard, but here we are. Students were polled at lunch about whether they preferred Nike or Adidas shoes. The data was filled in the table. Some data is missing. Is this the same data? Looks like it to me. Yeah, it is. Okay. So now basically what we're doing is we're taking the same data, and we can go ahead and just fill this in. And this time we're making a relative frequency table. So instead of just a two-way table, we're doing a two-way relative frequency table, which basically means instead of the numbers, we're going to have the percentages. And notice that the total is always 1. And when I say percentages, it's really decimals. Okay, so 1 is everybody. So in other words, 65 out of 65 would give me that number. So what I'm going to do is I'm going to go ahead and divide each number by 65 to see what proportion of everybody goes in that particular column. So this would be like 22 out of 65. This would be 11 out of 65. This would be 33 out of 65. And I'm not going to keep drawing the division on each one. I'm just making sure you see where those come from. Yes.
So for this like chart, what do we do by decimals or percentages?
When you divide, you get a decimal.
So you put decimals.
Yes. Yes. Okay. When you divide, you automatically get a decimal. Back here on the first page. Divide to find the decimal, and then multiply by 100 to find the percent if you're asked for a percent. If you're asked for a probability, we kind of like probability to be in decimal, so just leave it in decimal. But if it says something like, what percent of students do this, then you'd multiply the decimal by 100. Okay, so as a decimal, this gives me 0.34, 0.17, and 0.51. Now, these should add up to this, but here's the thing, is sometimes it takes a little bit of adjusting, or you got to appreciate the fact that you sometimes the rounding becomes an issue. You got to be careful with that. And so you kind of have to decide, how am I going to round so that these do add up to this? Like, what if this was actually 0.33? But we knew for whatever, like we knew that this was going to be 0.49. So we knew that this had to add up to 0.51, that kind of thing. So that might happen. It might not, but it might happen that you have numbers that are slightly off, sometimes like by 1/10 or 1/100th actually, because of rounding. Okay. But so for this column, you do 13 out of 65. This not column, this cell, you do 19 out of 65, and so on. Okay, so this is 0.20. If you haven't already started dividing, I'm trying to let you go ahead of me. So like I'm saying, for instance, if I do 35 out of 65, I get this, right? Well, that rounds to 0.54, okay? And then those two add up to 1. If it had been like, and these two do add up to 0.54, but occasionally you'll have a situation where they don't exactly do it. And you kind of have to, it's up to you how you choose to adjust it just slightly. Okay, but it's really just slight. Okay, so relative frequency notes over here. Relative frequency tables always have 1 as the grand total. Relative frequencies are found by dividing and rounding to the nearest hundredth. Correct. A relative frequency table helps organize data and describe associations between two variables easily. Okay, they also can be thought of as probabilities. Like if I were to just randomly select a student out of this whole table, the probability that I would select a boy who likes Adidas is 0.2. If I were to randomly select a student out of this whole table, the probability that I would choose anyone who likes Nike is 0.51. And so on. What is the strongest association between gender and shoe preference? Basically, they're telling me here, they're asking for the relative frequency. So they're asking me what is the highest relative frequency between gender and shoe preference? I would say that's this one. Boys who like Nike. The strongest association means that out of the people who were polled, most blank boys prefer Nike. What is the weakest association between gender and shoe preference? Which number is the weakest or the smallest? 0.17. There you go, right there. The weakest association means that of the people who were polled, most boys don't prefer, I'm sorry, most girls, thank you, don't prefer what?
Nike.
Nike. Among girls polled. So now this is, anytime they say something like among girls polled, and this is where we're going to get into more tomorrow, but among girls polled, that's narrowing down the group. So out of just the girls, so out of the girls are the 0.46. So out of just that total, what is the relative frequency of preferring Nike shoes? So that's 0.17 out of 0.46. This is actually a conditional frequency when it's just out of a certain group. Okay, that's what we're going to spend more time on tomorrow. So that rounds to about 0.37. So that basically tells me about 37% of girls, not of everyone, of girls prefer Nike. Questions there? Okay, I am going to let you guys do the back page here on your own. Notice that it's a relative frequency, not just a frequency table. Relative frequency because I see decimals. Okay, so that kind of means it's also like it's a probability table. It's got the probabilities. And all of the ones you see, these are like probabilities out of every one because the total here is 1. Okay, notice that back here when we did girls who liked or Nike preferences out of girls, that was not out of everyone. That was not one of the numbers you already saw here. The numbers you see here are out of everyone. We had to divide by just that row because we were saying just out of this group. So anytime it says just out of this group, then you have to divide just by that row or just by that column. Okay? Questions there? All right, then I'm going to go ahead and let you guys go. And tomorrow we will be synchronous, and tomorrow we will get into more specifically looking at conditional probabilities, which is more like the out of girls, how many prefer Nike. All right, see you later.